Now let's talk about how to add series lumped elements into our circuit. Suppose that I have a load impedance ZL that is 50 plus J 25 ohms. And I'm on a transmission line with a characteristic impedance of 50 ohms, and it's connected on this transmission line. And let's suppose that I have a length of 0.2 wavelengths. And then I want to add a series capacitor in here. And let's say that capacitor is 1 nanohenry and my frequency is 1 gigahertz. And I want to know how to get the input impedance right here at the front. Suppose I want Zn. So the first thing that I always do, I'm going to start with my load and I'm going to normalize so that I can plot it on the Smith chart. That means that I take ZL and I divide it by Z0, and that gives me 1 plus J a half. Let's plot that. Here's the real part of 1 and the positive part of a half, imaginary a half. So right here is my point, ZL. Now I'm going to need to rotate towards the generator 0.2 wavelengths. So what I'm going to do is take my straight edge and draw a line from the center of the Smith chart out through the point that I'm interested in, which is ZL, like this. And then I'm going to read off the location that I'm at. So right here, this number, which I just covered up, is 0.14 wavelengths. That's where I'm starting. That's what I see right here at the ZL. Now I need to move 0.2 wavelengths towards the generator. So right here it says wavelengths toward the generator. I'm going to be going in this direction, and I'm starting at 0.14. I'm going to add 0.2 wavelengths, which means I want to end up at 0.34 wavelengths. So let's look on this outside curve, this curve right here. So right here is 0.25, and I want to get to 0.34. Here's 0.32, 0.33, here's 0.34 right there. 0.34 wavelengths. I have gone 0.2 wavelengths towards the generator. Now let me take my straight edge. I'm going to draw a straight edge from my 0.134 mark to the center of the Smith chart, because that's where I'm going to end up, someplace on this line. And I need to know the magnitude. So I'm going to mark my ZL point by going from here to here and marking that on a piece of paper, moving the piece of paper down to the center of the Smith chart and marking my second mark right there. So that is telling me, let's call that point A. That is ZA, right here at point A. So now I need to add in my capacitor, but in order to do that, the next thing I need to write here that I rotated towards the generator, and I went 0.2 wavelengths in this case, and then the next thing I need to do is plot ZA, and let's read it. So ZA, and this is normalized, has a real part right here, pretty close to 1 still. That's chance. So let's say that's about 1 point, I'm just going to say it's still about 1. And we're on the bottom, so it's going to be negative. And our imaginary part right here is about 0.6. Then I need to denormalize, which means I'm going to multiply it by Z0. So ZA in ohms is going to be 50 minus J 30 ohms. Now what I need to do is calculate the impedance of my capacitor. So Z for the capacitor is going to be 1 over J omega C. So it's going to be 1 over 2 pi times 10 to the 9th, that's my gigahertz, times 1 nanohenry, which is 1 times 10 to the minus 9. My 10 to the 9 and my 10 to the 9s are going to cancel out. So I end up with 1 over 2 pi, and the J is negative, so it's negative J over 2 pi. Now I can see that my ZA, which is right here, and my ZC are in series. So if I want to know my input impedance, I simply add ZA plus ZC. Just be sure that they are both in ohms.